Hello students, today let us see how to find the resultant force of two forces acting on an object using the triangle law of vector addition. So first, let us go in a bit of details of triangle law of vector addition. So, suppose there is one vector here, vector OA. Suppose this vector is A bar. I'm going to draw another vector, say starting from point A here. This is vector AB. This is B bar. Then the vector that starts from O, that means whose initial point is O and the terminal point is B, that will represent the sum of the two vectors, vector sum of A bar and B bar. That means to apply the triangle law of vector addition, the second vector has to be drawn from the end point, the terminal point of the first vector. Then the third side of the triangle, which starts from the initial point of the first vector and ends on the terminal point of the second vector, will represent the sum of the two vectors. So let us see one problem here. Two forces are acting on an object as shown in the diagram. Find the magnitude and the direction of the resultant force acting on the object. So I'll put the diagram here. So this shows you the two forces acting on the object. Here, the first force F1 is of 10 newtons and the second force F2 is of 3 Newton. First force is of 10 Newton, second force is of 3 Newton. Now the force F1 is acting at an angle of 40 degrees to the horizontal, above the horizontal, and the second force F2 is acting at an angle of 30 degrees to the horizontal, below the horizontal. Now, the question is, can we use the triangle law of vector addition directly in this case? Obviously no. Why? Because both the vectors have the same initial point. And as I have made it clear, to use the triangle law of vector addition, second vector has to be drawn from the terminal point of the first vector. So, let us see what to do in this case. So, I'll make that clear by putting the next diagram here. So, as you can see here, what I had done is I had drawn a vector that is parallel to the vector OB, which is F1 here, and this vector I had drawn starting from the terminal point of F2. So I had drawn a vector CA that is parallel to vector OB and having the same magnitude as vector OB. So in this case, vector OB is equal to vector CA by the definition of equality of the vectors. Two vectors which have the same magnitude and the same direction are the equal vectors. So vector CA has the same magnitude as vector OB and also it has the same direction. So vector CA is equal to F1. So that means now this is 10 Newton here and this is 3 Newton here. Now, here the force of 10 Newton, that is F1, is acting at an angle of 40 degrees to the horizontal and F2 is acting at an angle of 30 degrees to the horizontal. That means this total angle here is 70 degrees. Now, you know that if two lines are parallel, then the vector, the angle that is BOC here and angle OCA, these are the interior angles. And interior angles are supplementary. That means since angle BOC is 70 degrees, 40 plus 30, then angle ACO, that is the interior angle, and that will be 180 minus 70, that is 110 degrees. So this angle is 110 degrees here. So now I will just draw only the vector triangle here. So as you can see here, F2, this is the force of 3 Newton, F1 is the force of 10 Newton, and the angle here is 110 degrees. So now I have completed the triangle. OC is F2, CA is F1, and the vector CA is starting from the terminal point of the first vector, and hence the third side, that is starting from O ending at A, will represent the resultant force of the two vectors. That means R is equal to F1 plus F2. Now already you have done the sine and cosine rules. When two sides of a triangle are known and the angle included between the two are known, to find out the third side of the triangle, you will use the cosine rule. So using the cosine rule here, how I will use the cosine rule? R square, that is the side I want to find out. Now here one side is having magnitude 3, another side is having magnitude 10. As you can see here, this side is having magnitude 3. So I can take this side as 3 here, this side as 10 here, and the angle included between the two sides is 110 degrees. So using the cosine rule, R square will be 3 square plus 10 square minus 2 times 3 into 10 multiplied by cos of the angle between the two sides, cos of 110. You know the cosine rule, which is in the form c square is equal to a square plus b square minus 2 times a into b into cos of c, where c is the angle between a and b. So if you calculate this, this comes out to be 129.5, and hence the resultant force, magnitude of the resultant force R, will be square root of 129.5, which is 11.4 Newton. Now I want to give the direction of this vector. Now direction of the vector I can give by giving this angle theta, which the resultant is making with the horizontal. Now already we know that the force of 3 Newton is acting at the angle of 30 degrees below the horizontal. So what I'll do is I'll find out this full angle and I'll call this as alpha. Okay. Now the resultant I have got here 11.4. Okay, so let me draw this triangle again, because otherwise it will become confusing. So I'll just sketch this triangle again. Now this side has magnitude 3, this side has magnitude 10, and the resultant we just now found, and that is 11.4 here. Also, we know this angle is 110. So, I will find out this angle here, that is alpha. Now, since I know one side and the opposite angle, and I want to find out one of the angles of the triangle, I will go for the sine rule. So, sine alpha divided by the length of opposite side, that is 10, and that is equal to sine 110 divided by 11.4, because 11.4 is the length of the side opposite to 110. So that means sine alpha is equal to 10 multiplied by sine 110 upon 11.4, and that comes out to be 0.82. Now sine alpha is 0.82, so alpha is sine inverse of 0.82, and that is equal to 55 degrees, which means this angle alpha is 55 degrees. Now, this is the horizontal line here, and this angle here is 30 degrees. I want this angle theta. Now full angle alpha is 55. Out of that, this much part is 30. So theta will be 55 minus 30. Theta is equal to 55 minus 30, which is 25 degrees. Which means the resultant force of magnitude 11.4 Newton acts on the object at an angle of 25 degrees to the horizontal above the horizontal line. Okay, so I think these concepts are okay with you. I'll just give you a similar problem here to do for the homework. So here the force F1, there are two forces acting on the object. So F1 is 15 Newton, F2 is 4 Newton. F1 is acting at an angle of 50 degrees above the horizontal, and F2 is acting at an angle of 20 degrees below the horizontal. So find the magnitude and the direction of the resultant force acting on the object. So that is your homework. Just try to do this. Any doubts, please ask me in the next class. Okay, so see you in the next class. Enjoy the day ahead, students. Bye.